Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting and a very relatable topic, that is data handling. Now in this chapter we will learn about the introduction, some important terms, organization of data, how we can find mean, median and mode, mean of tabulated data, median, mode, bar graph and pie chart. Now let's start with our introduction. Every day we come across a wide range of information in the form of numerical, figure, table or graph. Now through newspaper and televisions. Now the fact and information that are collected for the specific purpose, that is called our what? Data. Now we know that there are various types of data that are learned to collect data, tabulate and put it in the form of bar graph. So when we collect data and present it in the tabular form, there can be drawn many inferences on the basis of experiences. Now all kinds of data gives us some sort of information. Now the extraction of meaningful information from such data is studied in our what? Branch of mathematics, that is called statistics. Now for example, here we have given marks obtained by a students in class 7th. So here are the name of students, here are the maximum marks out of 100. Now here are our some important terms. Data is what? Collection of numerical figures providing some specific information. Now here are the examples that how many marks are secured by 10 students of class 7th in certain maths test. Now these marks forms the data related to the marks obtained by the students of class 7th in mathematics. Next is our observation, that means each numerical data figure in a data set, that is our what? Observation. Raw data, that means the numerical data recorded in any form, that is our raw data. Data are of two types, primary data and secondary data. Primary data that are collected by investigator or his or her representative with a definite objective in her mind is our primary data. Secondary data that are collected by someone other than the investigator. Array is the raw data that are arranged in ascending or descending order of magnitude. Range is the difference between the highest and the lowest values in the data. Frequency is the number of times an observation occurs in the given data is our what? Frequency. Now let's start with our organization of data. After collecting the data, it has to be put in a proper table so it can be understood and interpreted in an easy way. Now let's look at the collection of data. There are two ways of collecting data. First one is when the information is collected by an investigator himself or herself for the specific purpose and the data so found are primary data and the data are quite reliable. Sometimes it is not possible for an investigator to collect the data due to lack of money, time and resources, and the data collected by someone else other than the investigator, so they are known as secondary data. And the main sources of secondary data is data published by research organization, international organization or by central or state governments. Now how we can present data. Now after collecting the data, the investigator finds out the ways how we can represent them in a form which is meaningful and simple to understand and gives its main features at a glance. Now when the data are not arranged in any order, we call it raw data or ungrouped data. Raw data are not directly fit for interpretation, they fail to give us proper information. For example, here are the marks given by obtained by 20 students out of 50. Now the above data are not expressed in any order, so they are called raw data and each of its data is called observation. Now from the raw data, can you find the highest and lowest marks easily? Of course, it is time consuming to search minimum and maximum marks. Wouldn't it be less consuming if it would have arranged in ascending or descending order? So yes, in this we can clearly see that lowest marks is 3 and the highest marks is 45. So the difference between highest and lowest is what? Is our range, and here the range is 42. Next is our frequency distribution. The number of times a particular observation occurs is our frequency and the number of observation in a particular class is our frequency of that group. Now ungrouped frequency distribution, the presentation of data in ascending or descending order can be quite time consuming. When the number of observation in an experiment is large, then to overcome this, we prepared an ungrouped frequency table. To prepare an ungrouped frequency table, here we have to follow these steps. Here are the working rules. Step 1 says that you have to prepare a table with 3 columns. First is for variables or items, then for marks such as marks, weight, height or written, second is for telemarks, and third is for the frequency. Then we will place all of them in the ascending order. After that, we will take the first observation, match with the first column, we will put a bar in the second column, and we will continue this process until how many we have observations are given. Then we will put a suitable title which conveys the table, what the table is about. Here's example number 1. Here we have given the marks of 50 students in a class test are given below. Here we have arranged, we have to arrange the data in form of frequency table, then highest marks, then range of marks, and then which marks is occurring the most frequently. So here is our what in its table, and total is how many? Total is 50, and how many marks are more frequent? That is 9, and which is the highest marks? That is 15, and lowest marks is 0. Now next is our grouped frequency distribution. Now when the row data are in large number and the difference between the greatest and the smallest is large, we condense the data into classes or groups. There are two types of classes: exclusive class and inclusive class. Exclusive class, that means where the upper limit does not belong to the class. Inclusive class, that means where the upper limit belongs to the class. Exclusive class, here are the classes 0 to 10, 10 to 20 and so on are exclusive classes. In this class, 0 is the lower and 10 is the upper limit. We observe that upper limit of class is the lower limit of the next class. That means if the upper 10 belongs to the data, then 10 is not counted as a member of 0 to 10 but as a member of what? 10 to 20. Now the upper class is excluded from each class and hence named as exclusive class. Next up is our inclusive class. The classes from 0 to 9, 10 to 19. Here the upper limit belong to each class and hence are known as inclusive class. These are our what? These are inclusive classes that are equivalent to what? Exclusive classes. Now to prepare a group frequency table, we need to follow these steps. Here are the working rules. Step 1 says that firstly we group the data into different classes and then we will represent the data in each class by tally marks. The 4 consecutively tally marks are represented by vertical lines. The 5th tally is diagonally placed across the 4 tally. Counting frequency becomes less laborious. Now counting the tally marks in each case, the number of tally marks in each class is what is called its frequency. Always note that the data can be represented in different ways by choosing different classes. Next is our example number 2. Here we have the marks obtained by 40 students in an examination are given below. We have to prepare a frequency distribution table. Lowest marks is 31, highest is 89, range is 58. Now let us consider if we wish to distribute the above data in classes, then the greater than or nearest to 58 is what? 60. So the class size is 10 and we can say we can take the classes like this. Here is our class interval. Here is the tally marks and here is the frequency and total are 40. Now next is our mean median mode. We have learnt about collection, organization and tabulation of the given data. It is not that we have to already study the entire data to make sense of it. In fact, we make out of some important features by considering only certain representation. This becomes possible by using certain central tendencies or averages, and the commonly used are arithmetic mean, median and mode. Now let's start with our arithmetic mean. Arithmetic mean is what? The average of a given set of numbers or simply the mean. Mean is sum of all observation upon number of observations. In this example, we have to find the mean of each set of data. Mean of this data is 46.8. Mean of first 8 natural number is 1 to 8, that is 4.5. Mean of first 4 prime number is, that is 2, 3, 5, 7, 4.25. Mean of first 5 multiple of 4 is 12. Example number 4, here we have to find the mean of 6 numbers and we have to find the value of x, and mean is given. Mean is 7. After adding these, x is equals to what? 12. Next is our what? Example number 5. Here we have given the rainfall in a city on 7 days of a week was recorded as follows. Here we have to find the range, mean and on how many days rainfall less than mean rainfall. So range is 10.2, mean is 5.8 and the rainfall on Monday, Thursday and Sunday were less than 5.5 millimeter. Next is our example number 6. Here we have given the mean of 10 number is 25. If 4 is separated from each number, then what will be the new mean? This is our mean of 10 numbers, that is equals to 250, and new numbers are what? That is subtracted from 4, x1 minus 4, x2 minus 4 and so on up to xn minus 4. So the new mean is what? 21. Now let's start with example number 7. Here we have given the mean weight of 6 girls is 48 and the individual weight of 5 is given. We have to find the weight of 6 girls. So mean weight is equals to sum of weight of all the girls upon number of girls, and let the weight that is not given be x, and after solving this equation the weight of 6th girl is 53 kg. Now example number 8 is mean of 5 numbers is 25. If one of the number is excluded, the mean gets reduced by 2. So mean of 5 number is 25. So sum of 5 number is 125. And the mean of 4 numbers is 23. Sum of 4 number is 92. The excluded number is what? 33. Now let's start with the mean of tabulated data. If x1, x2 and so on up to xn are n observations with the frequency f1, f2 and fn, then the mean x observations will be x bar is equals to summation of fi xi upon summation of fi, where I is from 1 to n, and this symbol is called what? Sigma. That Greek letter represents our summation, that means the sum. Let's start with the example number 9. Here we have to find the mean of this distribution. This is our xi, this is our fi. When we multiplied it, it becomes fi xi, and the summation of fi xi is 8060, and the summation of fi is 40. So the mean is 21.5. Let's start with exercise 12.1 in the first part. Here we have organized the following marks in a class assessment in a tabular form. You have to arrange the data to form a frequency table. Which number is the highest? Very good, that is 9. What is the range of this data? That is 9 minus 1, that is highest minus lowest, that is 8 is the range. That's how you can solve the remaining ones. Let's start with the median. Median is what? The middle value of the set of observations arranged in either ascending or descending order. Let's start with the median of ungrouped data. Here are the working rules. Firstly, we arrange the data in ascending or descending order. Then we will determine the value of total number of observations. If n is odd, then median is n plus 1 by 2th observation. If n is even, then n by 2 observation plus n plus 1 2 by plus 1 observation upon 2 is our what? Median. Here's our example number 10. A student obtained the following marks in 15 class tests. We have to find the median marks. Firstly, we have arranged the data in ascending order. Now the number of observation is what? 15, that means odd. So n plus 1 by 2 is what? Median. 8th term, that is what? 25. Again, we have given the ages of 12 persons. We have to find the age of these persons. Firstly, we arrange the ages in ascending order. Then the number of observation is 12, which is even. So median age is n by 2th plus n by 2th plus 1 observation, that means 6 plus 7th observation, that is equals to 71 by 2, that is 35.5 years. Here you have to check your progress. Here you have to find the mean for these digits, that is 1, 2, 3, 4, 5. The digits are odd, that means the answer will be n plus 1 by 2, that means 5 plus 1 by 2, that means 6 by 2, that means third observation, that is 3 is our answer. Next is our example number 12. The following data have been arranged in ascending order. If the median of data is 35, we have to find the x. Now if in the given data 45 is replaced by 33, we have to find a new median also. Now the number of observation is how many? 10, which is even. So median age will be n by 2th plus n by 2th plus 1 observation. So that is equals to x is equals to what? 36. And if 45 is replaced by 33, then the observation are arranged in this order. The new median will be average of 5th and 6th observation, that is 33.5. Now let's start with the exercise 12.2. In the first part, we have to find the median of each of these followings. So here are how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 digits. Firstly, you will arrange it in the ascending order, and here the median will be n plus 1 by 2th observation. That's how we can solve the remaining part. Next is our mode. The mode is a score that appears most often in a given set of observation. It is that value of observation which occurs most frequently. Here's example number 13. We have to find the mode. Arranging them in the ascending order, 23 occurs 3 times. That means this is our mode. In example number 14, here we have to find the mode for the following data. Score 13 has what? Maximum frequency, that is what? 23. So 13 is our what? Mode. In example number 15, we have told that Khushi scored the following marks in various classes during a term test. What is our modal marks? That means firstly we arrange it in ascending order, and 16 appears many times. So that means 16 is what? Is its modal marks. Now let's start with check your progress. Here you have to find the mode of these numbers. So mode is 4 cannot be the mode, 13 appear twice, 9 also appear, 9 appear thrice. So that means 9 is what? 9 is the mode. That's how you can solve the remaining ones. In the example number 16, here we have given that we have to find the mean, median and mode of the numbers secured by 60 students in a class test of 10 marks. So mean is sum of observation upon number of observation, that is 4. Number of observation 16, n is given, that means average value of n by 2 plus n by 2 plus 1, that means 4.5, and the data which appears most time, that is 5, so mode is our 5. Example number 17, the number are these are written in ascending order. If the median is 5, we have to find x and find the mode also. So number of variations is 9, so n plus 1 by 2 is our median, that means 5th term. So 5 is equals to 2x plus 1 and x is equals to what? 2. So here we find x is equals to 2, and now the numbers are written in ascending order. So that means 5 occurs most frequently, so mode is 5 and x value of x is 2. Let's start with exercise 12.3. In the first part, we have told that a batsman scored the following runs in 10 one-day matches. We have to find his modal marks. So they are not arranged in our ascending order. Firstly, we'll arrange them in ascending order, that is 0. After that, it is 26, then 28, then our next number is 35, then 39. After that, we have 50, then 70, then 72. After that, 82 and 85. So these are the scores of a person in one-day test matches. Firstly, we arrange them in the ascending order. Now the frequency that has come the most number of times is our what? That is our modal marks, and there is no number that has come the most times, so there is no modal score. That's how we can solve the remaining ones. Next is our bar graph. A bar graph is a pictorial representation of numerical data using bars of different heights. Its features include rectangular bars are drawn in x's, value of those variables on the other side, bars equally distanced from each other, height of the bar dependent on the value of the variable, and width bar used be uniform. Here's our example number 18. The following table shows the data and the number of hours spent on various activities by Saurav in a day. Here are the activities, the number of hours, how we can draw data. Here are the working rules. Firstly, we construct two perpendicular lines, horizontal and vertical. Then horizontal is our x and vertical is our y. We take activities along x and number of hours along y. We'll choose a uniform width and a width gap, it should be uniform. Then we will choose a suitable scale to determine the height and then take 1 centimeter as 1 hour. And here's a bar graph which shows the number of hours spent on activity. This is our title, this is the number of hours, this is the activity, and this is our bar graph for the following table. Double bar graph. As we recall the construction of bar graph before, we learnt how about composite and double bar graph wherein two different values of the same variables are considered. In example number 19, we have given that the performance of two students, Rahul and Prachi, is given below. We have to draw a bar graph, double bar graph for the data. So the working rules are, again we will draw two perpendicular lines x and y as OX and OY. Along OX, we will mark the subjects at equal width and gap. Along OY, we will get the marks obtained. Now along OY, we have chosen the scale is 1 centimeter is equals to how many marks? 10 marks. Then we will draw a bar of equal width corresponding to the marks obtained by both the students. Here's the marks of two students, here's the marks and here is the subjects, and Rahul marks is represented by the grey lines and Prachi's marks is represented by the pink lines. In example number 20, here we have given that shirt of different numbers are sold by two ready-made shops are given below. We have to draw a bar graph for the data using the appropriate scale and answer the questions. So in the first part, in which measurement Fancy Clothes Store and has more shirts than Radha Fashion Store, and in which measurement the gap between the sale of shirt between the two stores is maximum. So here are the working rules. Firstly, we draw a horizontal and a vertical line OX and OY. Then the measurement of shirt lies on the x-axis and sale of shirt lies on the y-axis. Here's our fancy clothes store with the grey ones and Radha's fashion store with the pink ones, and this is the graph. So in the measurement group of 34, fancy clothes store sold 70 shirts, whereas Radha clothes sold 268 shirts, that means 2 less than fancy clothes store. Now in the measurement group of 36, Radha fashion sold store 94 shirts, but fancy clothes store sold 88 shirts, that means 6 more than the fancy clothes store. Now let's start with exercise 12.4. Here in the first part, a survey of 150 boys revealed their favorite game. Here we have to represent the data by bar graph. So here you can represent the game, and here you will be representing the boys. So let's imagine that our 1 centimeter represents how many? 5 boys. For example, firstly we have taken cricket and football only. So is our 0, 5, 10, 15, 20, 25, 30, 35. So for cricket, how many? Very good, that is 35, and for football that is 30. That's how you can complete the remaining ones. Next is our pie chart. A pie chart is a circular diagram in which observations are represented by non-intersection sections of a circle. The size of each sector corresponds to the magnitude of a frequency of each observation, and the whole circle represents the total sum of the observation, and it is known as what? Circular graph. Now central angle for a component is value of the component upon sum of values of component into 360 degree. Now how to make a pie chart or a graph? Firstly we calculate the central angle for each component. Then the central angle of the component is what? The formula we have just discussed earlier. Then we will draw a circle of the convenient radius. Then within this circle we will draw a horizontal radius. Starting with the horizontal radius we will draw radii, making corresponding angles equal to the value of the components. Now the radii divide the whole circle into various sectors, and we will shade each sector with different colors or designs. Here's our example number 21. The following table shows the expenditure in percentage incurred on the construction. Here is the item and here is the expenditure. Here we have to represent this data by pie chart. Total percentage is 100. Central angle for a component will be value of the component upon 100 into 360 degree. Now for brick, 54 degree. For cement, 72 degree. Steel, 36 degree. Labor, 90 degree. Miscellaneous, 108 degree. Now here are the working rules to draw a pie chart. The steps are very clear. Firstly we draw a circle of any radius, then we will draw a horizontal radius of the circle, then we will draw a sector starting from the horizontal radius with central angles, then we will shade the sectors differently using different colors, and we will label them. Cement pink, bricks grey, this is dark grey, then light pink, and then pink. Now let's start with our example number 22. The following pie chart shows the sources of fund to be collected by the National Highways Authorities of India in for its phase 2 project. We will study the pie chart and answer the question that follows. Sources of fund to be arranged by NHA for phase 2 project. What is the maximum number of funds required? That is, looking at the pie chart we can conclude that borrowing requires the maximum fund. Percentage of fund required for toll, that is funds for toll, and total funds percentage will be 8.5 approx. Central angle corresponding to annuity, that is 37.5 degrees, and here we have to find the appropriate ratio to be arranged through SPVS and market borrowing, that is 101 ratio 5.76. Next is our exercise 12.5. Here we have a group of 100 children were asked to make a favorite fruit, where we have to represent the data by using pie chart. So total is 100 students, and this is for apple it will be 24 by 100 into 360 degree, that is cancelled. 2 5s are 10, 12, then here it is multiplied by 12 into 36 by 5 degrees. That's how you can find it for orange grapes as well. That's how you can solve the remaining ones. Here's the project that you have to do it by yourself, students. Next is our chapter and exercise. Here we have to choose the correct option. A group of observation which is classified specifically in a frequency distribution table is known as group of observations that we classify in a distribution table. That is our what? Class. That's how you can solve the remaining ones. Mental maths. Here we have given the mean of 6 observation is this. If 5 of them are given, then we have to find the 6th one. We will suppose the 6th one as x, and this is 17.5 is equals to 25 plus 23 plus 10 plus 9 plus 14 plus x upon 6. That's how you can solve the remaining ones. Here's the activity that you have to perform it by yourself, students. Here's the session and reasoning that you have to do it by yourself. Now I hope you have understood the chapter pretty well. Just don't forget to revise this topic again.